Welcome to this introduction to R. This is the first of a series of videos that will help get you up to speed on the basics of how to use R. Now, R, the statistical software environment, has really revolutionized statistical computing since it was first introduced in about the year 2000. It was the very first free statistical software package out there that was fully functional, and also it provided ways for users to extend the capabilities of what R can do, extend it in a very easy manner so that other people can take advantage of those extensions. So if you would like to see a textbook introduction to R, let me get my red pen out here. There we go. My analysis of categorical data with R book contains much of the same content that I'm going to be talking about here. So first of all, as I said, R is free. You can download it from this particular link. R is available in a number of different operating systems, or for a number of different operating systems, where if you're interested in the Windows version, you can access it there. You can obtain other versions as well very easily from this original website. Now, when you install R, go ahead and go with all the defaults. They should work out fine. Do know that you will get two different versions of R, a 32-bit and a 64-bit version. It doesn't really matter which version you use. For what we will be doing, you'll get the same results. Okay, so when we open up R, let me actually go into R to do that, you will come to this screen here. This is the R GUI, or the R graphical user interface. And we have a window here that automatically opens when you open up R. It's called the R console. This is where we're going to type commands to do various operations. This R console can actually be kind of thought of as a calculator. So for example, at this command prompt, which is denoted by the greater than sign there, if I just simply type 2 plus 2, I get 4. If I type 2 raised to the third power, I get 8. But it also can do other kinds of calculations too. So from another stat course, you've seen a normal distribution before. And let's say that you want to know what's the probability that a standard normal random variable is less than 1.96. Well, we can type pnorms for probability norm, parentheses, 1.96, and parentheses, and we get 0.975. So 97.5% probability. Hopefully that sounds familiar in terms of the calculation itself. If I type log of 1, this actually is the natural log by default, and you get 0. You can use other stuff like a sine, a sine expression such as sine pi divided by 2. We can do fractions, 3 divided by 4, and so on. Now, very often when you do calculations like this, you would like to be able to save the results so that you can use it for future purposes and maybe reference it later. And to do that, we need to create what's called an object. And let's say I want to create an object called save, for the lack of a better name. And I want to save the results of 2 plus 2 into this object so that I can use it later. So the syntax to do this is that you have the object name, then a less than dash. Notice how this actually looks like a left arrow, 2 plus 2. So 2 plus 2 is going into the object called save. So if I hit enter, notice the results don't immediately come back to my screen for what 2 plus 2 is. Rather, instead, the results are saved in the object save. Now, in terms of naming conventions for objects, people often will use, let's say, like a camel case. So save it. Oops. So capital S, a capital I to represent that we have two different words here. More prevalently in R, you'll see somebody do something like this, save dot it. You can actually even use an underscore as well. Oops, not an underscore in that place. And use that. Now note that I could not do save space it less than -2 + 2. That would not work. I need some way of connecting the different words together for the naming. Now this less than dash that we see used here, that is often worded verbally as gets, G-E-T-S. So save gets the results from 2 + 2. Okay, so you're going to see me often look down to my left here. That's because I have my lecture notes that I'm looking at. Now, these objects are saved into R's workspace. And if you want to see a list of all the objects that are in R's workspace, we can type objects, parentheses and parentheses, and we see them listed there. Another way is to use ls, parentheses and parentheses. We get exactly the same thing. ls standing for list. For those of you who may be familiar with Linux operating system environment, you will see some common terms used, such as ls, in order to do particular commands in R. Now, this workspace that we see here, that now has 4 objects in it, that will remain there, available for you to use. So if I type save, I can access one object. It will remain there until you hit exit. So if I hit the X here in my window, look what happens. It asks me, do you want to save your workspace image? In other words, would you like to save these objects that you've created into a file so that you could use them later? Now, typically the way that we will use R, the way that most people will use R, you will want to hit no. Because as you will see in later videos, we will actually create a program of commands that we could just simply rerun later and recreate the objects. Okay, so I'm going to hit cancel here because I don't actually want to end my session. Okay, so R performs calculations using what are called functions. We've already seen some examples of functions such as log and also pnorm. Now, one of the nice things about R is that users can simply write their own functions. And this allows one to extend the capabilities of R. So let's take a look at an example. This is on page 4 of the notes. What I would like to do is create a function that calculates a standard deviation. Now, you've seen standard deviations before in previous classes. So I'm not going to go through the details of how the calculation is done, but rather we're going to write our own function to do it, taking advantage of actually some other functions. Now, there already happens to be a function R that calculates the standard deviation. That's fine. We're just going to create our own. So to calculate a standard deviation, I need some kind of data to work with. So I'm going to create an object called X, for the lack of a better name. And let's see here. And X is going to get the results from combining together a set of data values. So I'm going to use the C function. Hold on a second here. Sorry, I had to stop the recording there due to some technical difficulties. So what I'm going to do is create an object that contains some data that I want to calculate a standard deviation of. And to do this, I'm going to create an object called X, for the lack of a better name. I'm going to combine together the values 1, 2, 3, 4, 5. Those are my data values, let's say, just to make it simple. And the way I combine it together is to use a function called that's denoted by C. C for combine or concatenate. And so if I type X simply, we see my data. Now, as I said before, there's already a function R that calculates standard deviation, and it happens to be SD. So if I type SD parentheses and parentheses, we can see there's the standard deviation. But let's write our own function that does this calculation. So this function is going to be called SD2 for the lack of a better name. And this function is actually going to be an object too. So I'm going to say SD2 gets a function. And inside this function, I need to pass in some information that contains my data. In other words, my numbers. So I'm going to say function numbers, function parentheses numbers and parentheses. I could have called it something else other than numbers if I wanted to. And then to tell R where my main code for my function is going to start in terms of the body of the function, I'm going to use a left squiggly bracket. And notice when I hit enter, R comes back with a plus sign, meaning, okay, I'm waiting for more information. Now, one way to calculate a standard deviation is to simply take the square root of a variance. So I can type SQRT for square root, parentheses. I want to find the variance as well. And what do I want to find the variance of? Well, whatever's in numbers. So square root var numbers, var for variance. And if I hit enter, R is expecting, hey, you still need to give me more information. So that's why that plus sign's there. If I use a right curly bracket, that's going to end my function. And there we go. If I type SD2, we see the actual function itself. If I type objects, parentheses and parentheses, we see indeed SD2 now exists as a particular object. Well, let's actually try this out, this function. So if I type SD2, parentheses X and parentheses, we get the calculation. So this is a very simple function. We're not going to be writing too many functions during the semester, but it's good to have a basic idea of how these functions are written and what they represent. So again, just to review here, our function is SD2. To tell R we're going to create a function, we use the word function. And then inside the parentheses here, we have information that we can pass into the function to do some kind of calculations. For the lack of a better name, I use the word numbers to represent what I'm passing in. Then wherever I have numbers inside the function, R is going to recognize it as, in this case, X. When I actually run the function, I'm going to find the square root of the variance of what's in numbers. Okay. So a few more things about these functions. Now, notice that I could have done this. Let's see now. So let's say I want to save this calculation that we just did. What I could do is create an object called save.sd for lack of a better name. It's going to get the results from SD2 when I use X with it. And there we get the result 1.58. Now, the way that R is also set up is so that you could actually have multiple lines inside of function itself. But what's returned to the user in terms of the object that can be the numerical values that can be saved into an object is always the last line of what's in the function itself. So let's create a two-line function to help demonstrate that. So again, I'm going to call this SD2 for the lack of a better name, function numbers bracket. And let's say maybe I want to print my data. Then I'm passing in. And let me just type this real quick here, and then I'll explain what this all represents. Okay, so to print information from inside a function, one way to do it is use what's called a cat function. And again, if you're familiar with Linux, that name should sound familiar to you. If you're not, don't worry about it. Just realize that this is how you can print information. So cat, and then in quotes, I can put my data, and I want to print numbers. So the corresponding numbers of what I'm passing into the function itself. This /n here, this is just a way in R and also in Linux itself to represent move down to the next line. Okay, so if I hit enter now with this, and then if I again do my simple calculation for the standard deviation, now I have my function. I can actually see it. And if I type SD2 parentheses x in parentheses, we can see there's my data. Notice how things move down to the next line. And then also the final result of 1.58 that was calculated. And so if I also do save.sd again, notice how we still have some information printed to the screen, but what's actually saved in save.sd? Just that last line of code. So again, a key is that when you're writing your own functions or when you're looking at somebody else's function, it's the last line of code there that dictates what can be returned to the user that can be saved in an object. Obviously, we're just beginning here, and if this isn't clear, that's okay. We will see many, many more examples of this throughout the semester. Okay, so now we're on page 5. Now, at times, you're going to need help. And when you need help, what do you do? Well, you can talk to me, of course. But probably the first thing that you should do is use the help that's available to you in R itself. And so if I select help, HTML help, up will pop up a web browser. Unfortunately, it popped up into a different monitor window for me. So let me just move it over and make it a little bit bigger. And this is the basic help system for R. So for example, you'll notice that there are manuals that are available for free for how to use R. In terms of the reference area here, we have a search engine that you can use to do a keyword search to find help on a particular topic. But we're going to focus over here on this thing called packages. And the reason being is because this is going to help you also see how R is organized. R is made up of packages. These packages contain functions. They also contain data sets as well. And so if you want to get help on a particular function, it's helpful to know what package a particular function belongs to. So let's take a look at an example here. Now we've used a particular function called pnorm to find a probability associated with a normal distribution. Now, just from past experience, or you could do a keyword search to find this as well, I know that the pnorm function is in the stats package. So I click on stats, and if I click on P here, what you're going to eventually see as I page down, we're going to come to pnorm. So if I want help on the pnorm function, here it is. Now this help file actually gives help on 3 other functions as well associated with the normal distribution, but we're just going to focus on the pnorm here. Okay, so let's take a closer look at this help file and what it gives us. So pnorm is a function to calculate a probability with a normal distribution. Now inside the parentheses here, we see some information that's listed. In particular, the first thing is Q. And so if we look down here, Q stands for quantile. So back when I was using pnorm with 1.96, this 1.96 is a quantile. And in particular, you may have heard this terminology used in another class. 1.96 is the 0.975 quantile from a standard normal distribution. Also, you might have heard the phrase 1.96 is the 97.5 percentile from a standard normal distribution. So that p there in that help file represents the first value that you can put inside this function is this quantile. Now, something that's more helpful to do when you're using R is to actually include that p there. This helps you see, okay, yes, oops, not p, excuse me, q. Include the q there. The reason is because that helps remind you, okay, this first value that I'm using here corresponds to a quantile. So if I hit enter, I get exactly the same result. This q, and as you see as I go back to the help again, q, mean, SD, and so on, those are, you might think of it in other kinds of languages as options. In R, we call them arguments. So the q argument, the mean argument, the SD argument is what's associated inside the pnorm function. Now notice here with mean, it already has a value set to it, 0. SD, for standard deviation, already has a value set to it, 1. So in other words, we're working with a standard normal distribution, and since these values are already set, these are the default values. So let me go back here to R, and let's actually just type those values in there, and notice I get exactly the same thing. I don't have to work with the default values. So for example, let's say that I use a mean of 1.96. Now you should be thinking to yourself before I hit enter here, I wonder what that corresponding probability will be. If the mean is 1.96, I'm looking for a quantile, 1.96. Well, with a standard normal distribution, I know it is centered about the mean. So the probability that I should get back is 0.5. Okay. I could also change the standard deviation as well. And I could do a lot of different calculations. Now, as we take a closer look at this, this help file, notice again here we have the word arguments. Q is an argument, means an argument, using the terminology that I used before. As I page down here, you'll see some details. So you have a very crude representation of a normal distribution. We have information about, well, what value is actually produced by running the function. Some more of the computational information, some references, and then we have some examples. So what this allows you to do, these examples, is it gives you particular examples that you could run on your own. You can simply copy and paste these examples into the R console window, run them, and see what happens. So that's a great way of learning how to use R. Let me see where we're at here to make sure I've talked about everything that I want to. So again, become familiar with the names that I'm using here in terms of functions, arguments, stuff like that, packages. Okay, so now we're on page 9. Let me actually go over here, back to my Word document. Okay, so R allows you to work with what are called vectors in a variety of different ways. So vectors are, you could think of as sets of information. It could be data, for example, but it could be something else. If you've had a matrix algebra class in the past, you can think of the word vector as you would in a matrix algebra class. However, actually R treats it a little bit differently, at least for what we will be doing in our class. You won't see what that difference is. If you want to know the difference, take another class from me in the future. So R can, with its functions, can work very nicely with vectors of information. So let me actually copy and paste this code over to R. Okay, so we saw the C function before allows us to combine information into actually a vector. And so here I've combined in negative 1.96 and positive 1.96. And many functions in R are set up so that one could automatically do the same calculation on every element of a vector. In fact, pnorm is one of those cases. So if I use this vector with pnorm, notice I get both the probability of 0.025 and a probability of 0.975 with respect to this standard normal distribution. So that can greatly simplify your calculations rather than having to do these calculations, let's say, one at a time. Let me actually go back over here. Now let's look at how else R works with these vectors. So what I could do is create a vector, let's call it X, that has these particular data values in it. A vector called Y that has these particular data values in it as well. And as we've seen before, if I simply type X or if I type Y at the command prompt, what will come back then is the information that was saved in those particular objects. Now, if I were to type X plus Y, you might be wondering, well, how does R react in this situation? Because I don't just have, let's say, one value for X. I don't have necessarily one value in Y. I actually have, in this case, let's see, it's 3, 4, 5, 6, 7, 8, 9, 10. I have 10 different values in X. I have 10 different values of Y. Well, when you type X plus Y, though, at a command prompt, the way that R reacts is, okay, let's do element by element addition. So, for example, 3.68 plus 0.55 is 4.23. Well, what if I use, instead of a plus sign, suppose I use an asterisk to mean multiply. Again, we do element by element multiplication. So 3.68 times 0.55 is 2.024. Well, here's some other examples. Let's say that I want to find the average value of all the x's. As you might expect, there's a function that will do that in R for you. In this case, it's called mean. So if I do mean of x, I get negative 0.631. Well, what would happen, though, if I take these 10 values in x and subtract off the mean from them, from it? And again, I have 10 values in x. Mean of x is just one value. What happens? Well, what R does, it actually takes every single element in x, like 3.68, it subtracts off negative 0.631, it gets 4.311. Then it goes to the next value of x, negative 3.63. Let's subtract off negative 0.631. I get negative 2.99. So again, we have this essentially an element by element subtraction that's actually being done here. And again, the reason why this is being done is to help you save time, rather than having to take the first element in x, subtract off the mean. Then write code to do the second element of x, subtract off the mean, and so on. Another example here, let's say if I took x times 2, well, what happens is, again, element by element multiplication. So, similar to what I was saying here, the reason why this is done is so that calculations can be done in a more simple manner. So, for example, let me actually get the x's and the y's into R so that I can work with them. Just a second here. Okay. So, if I wanted to, let's say, access just one particular element in X, what I can do is use an index to get to it. So if I, for example, did X left bracket 1 right bracket, that gives me my first element of X. If I do it now with a 2 in there instead, it gives me the second element as well. So, other software, not software, but other programming languages might force you, if you want to add X to Y, to do calculations simply like this, where you go, oops, can't type fast, so that you would have to go through this whole process here. And if you have some programming experiences, you might have seen stuff like this, where maybe you use like a for loop to loop over all the index values. Here in R, you don't have to do that. So that can be nice. It can really simplify your life. Now, one thing also I want to mention here that's not in the notes, you might have seen me, let's say, type some stuff like really quickly. Like, for example, you can see here me going through a whole bunch of code that we've done before. I'm not actually typing it really quickly here with my hands. Instead, what I'm doing is using an up arrow. If I use an up arrow, it allows me to cycle through previous code that I've typed. Also, I can use the down arrow as well to cycle back in the other direction. Okay, so bottom page 11 now. So we've briefly talked about packages. Again, R is organized into packages. Each of these packages have particular functions, have particular data sets, and we'll see them throughout the semester. Now, when you install R on your own computer, you have a number of packages that are automatically installed with it. However, there are many, many, many other packages out there. I think we're at tens of thousands of packages. And these have been written primarily by users of R that were looking to extend the capabilities of what just the regular old basic installation of R can do. And so there are going to be some times this semester where we want to take advantage of some of these other great packages out there. And so we need to actually download them from a server on the internet, install them into R, and then we can use them. So here's a real brief description of how we can actually install some of these packages. It's actually rather simple. So if I come up here to packages, and if I select install packages, what will pop up, unfortunately, on a different monitor screen, we have what are called comprehensive R archive network mirrors that are all around the world. In other words, these are just computer servers that will allow you to download these packages from. And let's go to my favorite one here. USA, Iowa. This is actually at Iowa State University, their Department of Statistics. So I'm going to download packages from there. I should say that all these packages are exactly the same at each of these locations. That's why it's called a mirror. If I click OK, then what will pop up, again, on a different monitor screen, I actually have a 3-monitor environment here. We have a list of all the packages. And like I said, there are tens of thousands of packages out there written by users. One particular package that can be useful for what we do is called CAR, which stands for Companion to Applied Regression, which is actually a book. And let me see if I can find CAR here. Fortunately, since there's so many packages, it can be difficult. There we go. So if I select CAR and OK, you're going to see some information pop up on the screen that says, hey, now we're downloading information. We're downloading the package into R. Sometimes you will also see other packages that are automatically downloaded with the package that you're interested in, and that's what actually is happening here. And the reason why this occurs is because a package, like in this case CAR, actually uses information that's in other packages too. Generally speaking, you're not going to be downloading these many packages. It's just I have a brand new installation of R here right now, and as you can see, we are getting a lot of new packages that need to be installed. So unfortunately, that's what's happening. Now, let's see here. So let me go back to my notes towards the end. So it's important that you understand that R is case sensitive. So you might have saw me, for example, Fortunately, I can't get to my notes here or get to my R browser because everything, my R console window, because everything is actually being installed right now. You might have seen me use the camel case before, where I use an uppercase S and uppercase I for save it. That is different. If R recognizes that as being different from if I were just to say save it all in lowercase. So R is case sensitive, so you do need to take that into account. Excuse me, in your coding. Okay, so that then concludes this first part of the introduction to R.